All right, to name the following compounds according to Iupac, the first thing to do is to locate your longest carbon chain. And how do we locate the longest carbon chain? So let's try one and see how it goes. 1, 2, 3, 4. That's if I move straight. Okay, but this one seems to be the longest for this starting point. So I have 1, 2, 3, 4, 5. This is the longest for the starting point. Now I can decide also to change my starting point. Okay, so I can have a starting point here because this place actually signifies that there is a chain starting here. Okay, but this is not a starting point because the carbon is connected to other carbon. Okay, it's a secondary carbon, so it's not a primary carbon. A carbon that is connected to two other carbon cannot be your starting point. But this carbon can be your starting point because it's connected to only one carbon and is the one starting the chain. This can be a starting point. Okay, this can also be a starting point. Why should I pick this as a starting point? Because if I break the chain, I'll be having C, H, H, okay, C, all right, C, H, okay, I have H here, I have H, I have H. So what I have represented, what was there before is C3H7. So what I have represented is 1, 2, 3. That's 3 carbon. How many hydrogen? 1, 2, 3, 4, 5, 6, 7. So it's still C3H7, which means that I can decide to start from this place. If I want to start counting, I can decide to start here. Hence, when C3H7 is written together, like in the molecular form, we know that there is a carbon that would be starting the chain there. Does that make sense? So I can decide to start 1, 2, 3, 4, 5. I can decide to go straight 1, 2, 3, 4, 5. So in other words, what am I saying in essence? There is a starting point in C3H7. So I'm cleaning it because I don't want to, I am not interested in the structural form of representing it. So I can have C3, my C3H7 back. Now, if I also pick this carbon, this is also a starting point. So I can decide to go 1, 2, 3, 4. Okay, I can also decide to go 1, 2, 3, 4. I can also decide to go 1, 2, 3, 4, 5, 6, which is this if I go this way. So it means that we have a starting point that is having the longest carbon chain now. Once you locate your longest carbon chain, what's the next thing to do? Just number it forward and backward. Okay, so numbering forward, how am I going to do it? I have 1. Because I know there are 3 carbons here, I'm going to name 1, 2, 3 here because of the 3 carbon. Does that make sense? Then I have 4, I have 5, I have 6. Okay, then number it backward. What am I going to have? 1, 2, 3, 4, 5, and 6. Good. Now, after numbering forward and backward, that's the longest carbon chain. Okay, a carbon atom that is not numbered becomes a substituent or a non-hydrogen atom. So I'm looking at the carbon atom that is not numbered now. So for this carbon atom does not have this red ink number. Okay, so it's standing alone. If you look at this carbon atom too, it does not have that red ink. This 4 belongs to this carbon and this 3 still belongs to this carbon. So which means that this will be a substituent. This I am cycling will be a substituent. Why am I calling the substituent? Because it does not have a number and because it is not part of the longest carbon chain. It's as simple as that. Now, for this CH3 too, I'm going to circle it because it's not part of the carbon atoms that I numbered. Does that make sense? So which means that we have 2 substituents. These substituents are alkyls. Why do I call them alkyls? Now, you see, if I have alkane, okay? Alkane, the first alkane that we have is methane. Methane is what formula? CH4, okay? Then there is something we call alkyl. Now, you see, when a parent alkane loses one hydrogen atom, in other words, this CH3, this CH4 now is methane. But when methane loses one hydrogen atom, it becomes methyl. It becomes methyl. Does that make sense? So when it becomes methyl, what happens? The formula would not remain as CH4 again. What it will remain as is CH3. Now, the CH3 dot. Why am I putting a dot? Because the structure is CH4. Okay, CH4 this way. This carbon is connected to 4 hydrogen atoms. Now, when one of these hydrogen atoms breaks out, this bond must break because before it can separate. So when the bond breaks, how many electrons are in this bond? 2 electrons. One was contributed by hydrogen and the other by what? By carbon. So when the bond breaks, each of them takes back their electron. Okay, like dot and cross. Okay, now when the hydrogen separates, what happens? The hydrogen comes here and the CH3 remains as CH3. Okay, so what do we have? We have a dot. This dot that I placed here is the electron for the CH3. So as we go further in organic chemistry, I will show you how to use that electron very well. So the next member after methane is ethane. Okay, so ethane, we have C2H6. C2H6. When C2H6 loses one hydrogen atom, it leaves the name alk. Instead of having ane at the end of the F, it would instead have ew instead of ane. Does that make sense? So instead of us having ane, we'll have what? We'll have ew, which is YL. So we'll call it ethyl. Now, because it is losing one hydrogen atom, what happens? It becomes C2H5 dot, and so on forth. Do you understand? So we can have propane and we'll have propyl by the loss of one hydrogen atom. We can have butane and we'll have butyl by the loss of one hydrogen atom. So what's happening here? How can we apply that knowledge to this compound here? So from what I cleaned, I know that CH3 means methyl. Does that make sense? Because CH3 is assumed to have lost one hydrogen atom from the parent alkane already. So this CH3, this is also CH3. Forget the fact that it's in a structural form, it's still CH3. So which means that it can be in structural form, or I write like this as molecular formula. Does that make sense? So since I have two methyls that are substituents, I will ask myself a simple question. These methyls, to which carbon are they connected to on the longest carbon chain? Now, both of them are connected to this particular carbon. This particular carbon is part of the longest carbon chain, and that is why it's having these two numbers. Okay. Now, there is a rule of naming that says substituents must take the lowest possible number. Does that make sense? Right. So between 4 and 3, which one am I going to pick? I'm going to pick 3. Why? Because 3 is the lowest possible number on this carbon and on the carbon to which these substituents are connected. And it's as simple as that. Now, there is a warning about this. Once you pick the lowest number as 3, you see this 4, you have to clean it immediately. And you will not only clean the 4, you clean every other thing, that's every other number that is connected to this 4, which means that this particular 4 here, I have to clean it off. I have to clean this, okay? I have to clean this because it's connected to that 4. So which means that I will eventually have a system of number, which is 1, 2, 3, 4, 5, 6, okay? Which is the longest carbon chain. So let's write it down. Now, this methyl and methyl is connected. It means that they are connected to carbon 3. That makes sense. So I will have 3, okay? So I have 3 methyl, which means that I'm representing this particular methyl connected to carbon 3. And that's why I'm calling it 3 methyl. Now, there is another carbon, there is another CH3 again. So there's another 3 methyl, because this one too is connected to that carbon, which is this carbon 3. So I can write as 3 methyl. So how many methyls do I have? I have a methyl, I have 2 methyl, I have a methyl here, I have a methyl here. Do you understand? And both of them are on carbon 3, carbon 3. That's what it means. Now, what's the longest carbon chain? The longest carbon chain is 1, 2, 3, 4, 5, 6, which means hexane. When the longest carbon chain, or you have 6 carbon, it is a hex. Do you understand? Now, it can now be a hexane, it can be hexyne. Does that make sense? The reason I called it an ane is because between each of this this carbon atom, we have only single bonds, and those single bonds represent saturated hydrocarbon, and the only saturated hydrocarbon we have under that classification is actually the alkanes. Does that make sense? Hence, I will end it with ane. But if it happens that I have double bond, then I will end it with what? In, something like that. Okay. Now we are not done, because the writing this like this is not correct. So how can we best write it? Because I have 3, 3, and the two are still methyl, I'm going to combine these two, right? Hence, I'm going to call it 3, 3. Does that make sense? Then I'll have dash. Then I'll put dimethyl. Why am I using the Greek prefix di? Because I have 2 of the methyls. Does that make sense? Then I have hexane. Now, take note that if you write that's just 3 dimethyl, it means that you have lied. If you just write 3-dimethyl like this, you have lied because you are saying there are 2 methyls, but you are representing one number here, right? So it's not making any sense. So you have 3, then it must be a di. But if you have 3, then it cannot be a di. Then it can only be 3-methyl hexane. Do you understand? But now that we have 3, then it will be 3,3-dimethyl hexane. Now take note, between numbers and numbers, you use a comma. Between number and letters, you use a word. You use an hyphen. And this is the name of this compound. Let's give it a try for this. So I have this compound. Now the first thing I'm to do is to locate my longest carbon chain. Now how do I locate my longest carbon chain? I will have to count the carbons, okay? The one that is the longest. And don't forget, I told you that any carbon can be your starting point, provided that that carbon is the one starting a chain. Does that make sense? This carbon is telling us that we have 1 here, okay? Why can't I count the longest carbon from this carbon? I cannot use this carbon to start counting because this carbon is not the one starting the chain. The chain, there is a chain connected to this carbon, which is this guy here. This guy is connected to this carbon atom. Hence, this one cannot be the first carbon that you're counting when counting the longest carbon chain. That makes sense, right? So how am I going to count? I'm going to start from here because this one is not connected to two other carbons. It's only connected to one, which means that it's the one starting the chain. Does that make sense? So I'm starting here. So if I count from here, what am I going to have? I'm going to have 1, 2, 3, 4. That's provided I didn't branch, okay? I have the liberty to branch, but I just decided to count like that, okay? So I can also decide to count this way. 1, 2, 3, 4, if I like, okay? If I also want, I can decide to count this way. 1, 2, 3, 4, okay? Which means that I can use any of this chain, right? So, but the chain I'm going to use here is 1, 2, 3, 4, right? So, which means if I go this way, I'm going to have 4 as the longest carbon chain, okay? If I change the starting point, if I'm not using this, if I'm changing the starting point, I will say I have 1, 2, 3, 4 as the longest carbon chain. 1, 2, 3, 1, 2, 3, which means that the longest is still 4, right? If I start here 1, 2, 3, 4, or 1, 2, 3, 1, 2, 3, is still 4. Is still 4 as the longest carbon chain. So preferably, let me use this. Now, let me quickly show you something. But before I show you that, probably I will repeat this compound. I will show you a trick that you must be very careful about while naming this compound like this. Okay. So what do I have? I'm numbering now. 1, 2, 3, 4. Okay. So I've numbered forward. Now I want to number backward. 1, 2, 3, and 4. It's as simple as that. Now the rule says that once you have numbered forward and backward, that is once you've located your longest carbon chain, the next thing to do is to locate your substituents. Now, what are substituents? Your substituent can either be an alkyl or is a functional group. Does that make sense? Now, this is an alkyl because it's falling as one of the alkyls that we have. So it's a methyl, right? This is also a methyl. So why am I circling these ones? Because they don't have a number on them. Okay, they are not part of the longest carbon chain, and it's as simple as that. Now, this guy here is actually a substituent because it's a non-hydrogen atom, right? Because it's a non-hydrogen atom, we have bromine has a substituent. But this time, the kind of substituent it is actually a functional group. So how are we going to name the compound? So our longest carbon chain happens to be 4. But then, whenever I have a functional group and a substituent in a particular compound, which one am I to prioritize? Which one am I to count first? Just that you are to give priority to the functional group over the alkyls. So in that sense, what am I having? It means that the number one, which is bromine, I'm picking the lowest number for this bromine. So I have only 1. That is as simple as that. Now for this now, because I have picked 1 for bromine, I would trace the number out. Okay, this is the number, which means that I will cancel the whole of this. Now, failure to clean this number means that you can come back here to pick 3, which is not part of the number that you are actually using. So what am I going to do? I'm cleaning this, I'm cleaning the whole of this, which means that I will have a system of number remaining. So I have 1, 2, 3, 4, and that's as simple as that. So if I will name the compound, how am I going to name it? I'm going to have 1-bromo. Why am I calling it 1-bromine? Because bromine is falling on number 1. Okay. Then I have I have methyl. Both methyls are connected to carbon 2. So I have 2, 2. Why am I writing as 2, 2? Because I've taught you that before, that when you have repeating substituents or repeating alkyl connected to a particular carbon, you repeat the number. Does that make sense? So I have 2,2-dimethyl. Why am I calling dimethyl? Because I have 2,2 here. That makes sense, okay? Or because I have 2-methyl connected to carbon 2. That's as simple as that. Then the longest carbon chain, then that becomes a butane. So I have 1 bromo, 2, 2 dimethyl butane. And it's as simple as that. Now, I am repeating this compound for a particular reason. I just want to show you something. Right, okay? So I have C, CH3, H, okay, H, I have C, CH3, right, CH3, I have C, bromine, I have hydrogen and have hydrogen here. Okay, so I told you earlier that you can use any longest carbon chain, but there will be a problem, okay, and the problem is simple. Let's assume that I'm not using this chain. Let's assume I'm using this particular chain here as my longest carbon chain. I'll have 1, 2, okay, let me put it here, 1, 2, 3, and 4. Okay, I'm moving like this. So I'm numbering backward. 1, 2, 3, and 4. Okay, so I have a system of number in between all of them. Then I have one surrounding the carbons. Now, it means that this becomes my substituent, and this will also become my substituent because you have to circle everything around the carbon that you're picking. Does that make sense? Okay. Now, to name this guy here will be very, very difficult. Do you understand? So, which means that despite this is the longest carbon chain, or despite this is your longest carbon chain, okay, you must check your substituents to see if it is something you can name. But if it's not something, you check if there is another longest carbon chain that will make the work much more simpler for you. Does that make sense? But I know that what you will end up having is the same, it's supposed to be the same name, okay? But naming it this way might be a bit difficult for you. Enjoy the rest of your day and see you in the next one.